All right, everybody. Today's the day for the most glorious of topics, factoring on bots mode. The hard shit. But first, there's a little more I wanted to do with the systems of equations. We were doing 2x2s and 3x3s, but sometimes we don't have enough equations for the variables we have. And so what happens with something like that? Let's take a look at it. So the example I'm going to do for this first thing is we're going to have 3x plus y minus 2z equals -7. And we have 5x plus 2y plus z equals -6. So let's say, I don't know, we get rid of y first. I'm going to take this, I'm going to multiply this by -2. And I'll write it down below. I've got -6x minus 2y plus 4z equals 14. Maybe I'll do my labeling thing. A, B. And this is going to be b minus 2a. So I add these together, I get -x plus 5z equals 8. And if I solve this for x, I will get 5z minus 8. We're not going to be able to find a value for these numbers. So the best we can do is make a relationship between one variable and the other variables. So what I'm going to do is I'm going to take this. Here I have x in terms of z. It was the easiest one to do without having fractions, which is why I did it this way. I could have solved for z and had it in terms of x, but then I went out of fractions. So if I want to remain with something, the goal here is to end up with my x, y, z being something like this. 5z minus 8 is my x value. My y value, I want to write it in terms of z as well. So the best we can get it down to is pick a z, find the rest of the points, find the point that works on both. So I've already combined the only two equations I have. There's no other combinations I can do, so the best I can do is just plug one back in. So I want to get something in terms of y. A already has y by itself. So I'm going to plug in there. So I'm going to take that, plug it in, and I'll bring it down here. And I've got 3 times 5z minus 8 plus y minus 2z equals -7. Do some cleanup here. Oh, that's not -8, that's -24. I'm going to combine the z's together real quick. And I'm going to add 24 to the other side. And that'll give me a 17 over there. finally solving for y, I get negative 13z plus 17. That's the best we can do. You should be able to get the same thing plugging into the other one. If you plug in x up here, you should get the same value for y when you solve for it. So we don't have an actual value. Like when we solved the 3 by 3, we were able to come up with an actual coordinate. But whether you know it or not, when we have 3x plus y minus 2z, this is actually the equation of a plane in 3 space. So it's like in the real world having a plane, and then I've got a second plane. Maybe I should do it over camera. I've got a plane like that. And then I've got another plane like that. And I only have 2 planes, but notice that they intersect in a line. Like if I look at it another way, they intersect in a line. So we get, this is giving us the equation of that line. That's the best we can do with that. Isn't that fun? Now, on to boss mode stuff. Let's do partial fraction. Is there any questions on that before I move on? This is not necessarily intuitive. We like getting a value. Here we can't. We just don't have enough equations. But that's the best we could do. So if you've only got, we start off with 2 equations, but 3 variables. If you have more variables than equations, you can't get a value for each thing. You can only get something, one of them in terms of the rest, or all of them in terms of one of them. It's even worse when you're missing 2 equations. Then you have to, it just gets ugly. Doesn't happen all that often, but I'm sure the homework's going to have something where they ask you for it. You will do stuff like this in calculus 3. That is a long ways away though, and that's when we start working with 3 dimensions anyways. And so you'll have more practice with 3 dimensions by then anyways. All right. So, partial fraction decomposition. This is the cream of the crop right here. I love this topic because I think it's really fucking neat how it works. How this falls out. Let's start with going the wrong direction. Let's go the other way first. Let's say we start off with 3 over x minus 2, and we added 2 over x plus 3. That's what we start with. I'm gonna take the 3 over x minus 2. I'm gonna multiply by the other denominator real quick. And I'll do the same thing for with this one. I clean this up. I get 3x plus 9 plus 2x minus 4 over that fraction, or over that denominator. And I put it together and I get 5x plus 5 over x minus 2, x plus 3. I could factor it and do like 5 times x plus 1, but it doesn't cancel anything out. So I'm not going to do it. My left side is still 3 over x minus 2 plus 2 over x plus 3. So what we did is we combined fractions or did a composition of fractions by finding a common denominator. We've done this before. This is old news. I'll give everyone a chance to write that down before we proceed with the glory. This is a very valuable skill in Calculus 1. It doesn't show up in a lot of problems, but when it does, it makes shit a lot easier. And if you learn it now, you will be better off. So, how do we go the other way? How do we uncombine fractions? Or to put it in the terminology that we use here, how do we decompose the big fraction into smaller parts? The idea, the most simplest idea we're going to start with is this. If the big fraction has an ax plus b in the denominator, the decomposition will have a over ax plus b in it, where a is a constant. Let's see how that works right here. Let's say, what the fuck is Mr. Jones talking about here? So I'm going to pretend I don't know that this ends up with a 3 on top and a 2 on top. Let's find out how we get that. I'm going to start with 5x plus 5 equals x minus 2 times x plus 3. And I'm going to find it now. I know that I should have a term that has an a at each one of these factors on the bottom. I should have an x minus 2 on the bottom of one, and I should have an x plus 3 on the bottom of the other. And rather than use the same letters, I'm going to call it a and b. Okay. So this is a lot like, we're not technically clearing fractions. We should be finding a common denominator. But I think it's a lot easier to clear fractions. Like, let's just multiply through by x minus 2 and x plus 3. Technically, we are just getting a common denominator. And this will just show the numerator. If I do that, I'm going to have 5x plus 5 equals a times the x minus 2 cancels for the a, but it still has the x plus 3. And for b, the x plus 3 cancels, but I still have the x minus 2. This is a lot like writing x plus 3 there, x plus 3 here, x minus 2 here, x minus 2 here, and then just looking at the top. I got a common denominator for all of them. I'm just looking at the top, but who wants to keep writing down the denominator when you don't need to? I thought I'd show it real quick though to show how it works. I'm not just making shit up. But now we have something that goes together. These should go together and make the 5x plus 5. So the way you go about doing this is multiply this shit out. You got ax plus 3a plus bx minus 2b. Now, group them like they are on the left. What I mean by that is put the x's together. If I put the x's together, I have a plus b times x. And I have plus 3a minus 2b. I'll make sure everybody's going on the same page as we go through this. This is one of the longest processes that you do in algebra. It's just that there's a lot of steps. We've already done a lot of steps already. And we're nowhere near the answer. Well, we're about halfway. I'm going to read it right down on the left side. I should have been doing it the whole way, but I was being lazy. The idea here is if these two are equal, then the coefficient of x should be equal. A plus b should equal 5. And my constants should be the same. 3a minus 2b should equal 5 as well, because that's the constant there. Well, now I've got a set of 2 equations and 2 unknowns. We just got done doing how to do this on Tuesday. So let's solve this for A and B. Let's find out what A and B are. So I'm going to double this one. It looks like getting rid of the B's is probably the easiest way to go. because the b is already negative on bottom. And I add this together. And I get 5a equals 15, which means a equals 3. And I take a equals 3, and I'll put it in there. And we get 3 plus b equals 5. B equals 2. Almost done. We're almost done. Now recall, we started off with, we said this was a over x minus 2 plus b over x plus 3. Now we just plug it in. 5x plus 5 over x minus 2 times x plus 3 equals 3 over x minus 2 plus 2 over x plus 3. And look at that. That's what we started with. It's fucking pretty cool. I don't see enough. That's pretty cool. Mr. Jones' faces is out there. I should see more faces that go, that's pretty cool. We took a shitty fraction. This is arguably a shitty fraction to work with. Like, how do you pull that apart? We just figured out how to pull apart. And all it did is saying, let's just take the fraction and pretend there's a fraction with each of the denominators, make up some variable to put on top and figure out what those values are. It's kind of crazy. You guys ready to do some more? All right, now let's pick one we don't know the answer to and do it. Let's start off with 11x plus 2 over 2x squared plus x minus 1. I need to factor this. I should have a 2x in the beginning of one of them. And I have to have ones at the end over here. So I need a positive leftover. So if I do +1 here and -1 there, I should get the right combination. Now, what I'm going to do is just split that into two fractions. I don't know what's on top. Let's figure it out. If I go through and multiply by the common denominator, multiply by 2x minus 1 and x plus 1, I get the left side, the denominator just goes away. The right side, the a term, the 2x minus 1 gets wiped out, but the x plus 1 stays. And the b term, the x plus 1 gets wiped out, but the 2x minus 1 stays. So it's kind of like just take that and kind of move it up there and take that and kind of move it up there. It's a little more complicated when there's more than two. But when there's only two terms, that's pretty much what we're doing. Everyone with me? Let's multiply it out. To bx minus b. And we're going to group the x's. A plus 2b times x plus a minus b. That's my 11x plus 2. And this is probably going to be extra credit on the final too. I already know one of the extra credit problems on the final. It's going to be a 4x4 problem. 4 variables, 4 questions. We were talking about it in the last hour, and I thought, you know what? That's fucking kick ass. We did an example. Unfortunately, it had fractions all the way fucking through it at the end. That was shitty, but it was doable. All right, so again, we got to match up coefficients. X's coefficient is these. So I got a plus 2b equals 11. And my constants are a minus b and 2. What happens if I just subtract this bottom one from the top one? So if I subtract, I have a minus a is 0a. I've got 2b minus a negative is a plus. So 2b plus b is plus 3b. And 11 minus 2 is 9. That's effectively me multiplying through by a negative. So that I can add them together. We don't need the 0a. I just showed it to make sure everyone was on the same page. We divide by 3. And we get b equals 3. Here I had a minus b equals 2. I plug that in, a minus 3 equals 2. And I get a equals 5. So when I put this all together, I had 11x plus 2 over 2x minus 1 times x plus 1. I had 2x minus 1 on the bottom of one, x plus 1 on the bottom of the other. A goes on top here, b goes on top here. Can I check my work? How could I check my work if I wanted to check it? What? What do you mean? We did plug in 5. We got plugged in A is 5. We plugged in B is 3. How can I show that these actually equal that? Same thing we did on the first part, find a common denominator. So you can check your work. By finding a common denominator. In this case, I would have the 5 over 2x minus 1 and the 3 over x plus 1. And I would multiply this one by x plus 1 over x plus 1. And I would multiply this one by 2x minus 1 over 2x minus 1. And I would show that I got 11x plus 2 on top. I think you'll see that works here. If you just do the numerator here, you have 5x plus 5 plus 6x minus 3. And you'll see that ends up giving you 11x plus 2. Okay, there's a couple other variants we got to look at. Make sure everyone's had a chance to write this stuff down. All right. So we showed the case where this has a parentheses, a little linear part on the bottom. If we have something like ax plus b on the bottom to like the nth power, what this is going to turn into is something, I don't want to say one, I'll say a over ax plus b plus b over ax plus b squared plus c over ax plus b cubed plus dot dot dot, you go up to n over ax plus b to the n. Usually this doesn't get bigger than 2 or 3. Usually 2 is the cap. So that's what happens when you have things that repeat. The other weird thing that shows up is if we have something that just doesn't factor beyond ax squared plus bx plus c on the bottom. And let's say there's obviously other parts. This ends up having the same denominator. And we know there's a constant there, but there might be an x. So it goes like that. So it goes 1 degree smaller on top. This had an x squared, so the biggest we have on top is an x. There's a lot of shit going on here, right? These kind of things show up though, like if we factor a cubic, You know, we've done factoring cubics. There is something that has x squared plus an x plus c kind of thing. All right. Let's take a look at doing something like this. Yeah. We are going to have negative 2x squared plus 7x plus 2 over x times x minus 1 squared. Okay, so we know this is like, well, it's that one there. We have an x there, so we should have a term that just has an x on bottom. And we should have a term that has just x minus 1 on bottom. And we should have a term that has x minus 1 squared on bottom. We're gonna, since this is a square, we're gonna keep doing these until we get up to the value of the exponent. If this was a cube, we would do a d and x minus 1 cubed, but it's not. So, same process. Multiply through by the denominator. I'm gonna like spell it out a little bit easier because it might be easier to show what you get on top. That's my left side. This one is going to cancel with the a. So I have a times x minus 1 times x minus 1. The b one, this one is going to cancel on the b. So I'm left with the x and the x minus 1. And both of these cancel with c. So I'm just left with the x. Teaching partial fractions decomposition at college for students right now. Good times. Is everybody okay with that? I didn't write it all out. You just got to kind of go through and go, okay, the x goes away for the a, and this is what I'm left with for a. The middle one goes away for the b. And I'm left with x and x minus 1 for the b. And then the c, x minus 1 squared, both of those go away. And I'm left with the x for the c. All right, so again, we got to multiply this shit all out. So this is x squared minus 2x plus 1. And if I do a times that, I have ax squared minus 2ax plus a. I do B. I've got bx times x is bx squared. And bx times -1 is negative bx. And cx is good to go. Now we start grouping our x squareds. So I have an x squared here and an x squared here. I've got a plus bx squared. At this point, I recommend you underline shit as you're using them. That way you make sure you get everything. By the time you're at the end, you should have everything underlined. Then I'm going to go through and do my x's. I have xx, or I have x's there, there, and there. I've got negative 2a plus b plus c x. And then for the constant, all I got left is a. All right, so let's start comparing coefficients. I've got a plus b has to equal -2. That's my x squared term. I have negative 2a plus b plus c has to equal 7. That's my x term. And my constant just gives me a equals 2, straight out the gate. Well, that's pretty fucking handy. That's really handy. That's gorgeous. Because I've already got, now I've got A, I need B, and I need C. Well, I know A equals 2, so I can plug that in over here. 2 plus B equals -2. So B equals -4. And now I've got those, both of those, I can plug those in here. I've got -2 times 2 plus -4 plus C equals 7. This is C minus 8 equals 7. So C has to equal 15. They have another value. What am I doing wrong here? That's a minus B. That's the problem. So I just get C equals 7. There's a shorter way of doing this. Let's see. Let's go back up to, so we got these values right here. Let's just write down the final form real quick. It's A over X, which is 2 over X, plus B, which is -4 over X minus 1, plus C, which is 7 over X minus 1 squared, which is 7. I don't know why I wrote C. And if we wanted to keep this positive right here, I could make this negative right here. It's got a little tedious though, didn't it? A little bit. Check out this shortcut when you guys are done writing that part out. Yeah.
And this would all be equal to that -2x squared plus 7.
Yes. Let me put that in. Okay, let's go back to this line right here. Right after we cleared the fractions. Because doing this could have given us an A, B, C on all of them, and this could have been shitty. I would have had to do a 3x3 set of equations, which can be very, very crappy. So let's go back to when we first cleared fractions. And I had -2x squared plus 7x plus 2 equals A times x minus 1 squared plus bx times x minus 1 plus cx. And the reason why I think it's easier to treat this as clearing fractions, because what I'm about to do now, you can't do when there's a denominator. What if I plug in x equals 1? This term goes to 0. This term goes to 0. I have -2 times 1 squared plus 7 times 1 plus 2 equals 0a plus 0b plus c. And without having to do a 3x3 system of equations, I find out right away that 7 equals c. which is what we had here. And what if I do x equals 0? This is 0 plus 0 plus 2 equals a times -1 squared plus 0b plus 0c. I get 2 equals a. Look at that. That's what we had right there. Once you know these two, you can just find b by plugging everything in. I have 2 times x minus 1 squared plus bx squared minus b, sorry. And then c was 7. So 2x squared minus 4x plus 2. This is x squared minus 2x plus 1, and then I'm doubling it, plus bx squared minus b plus 7x equals the -2x squared plus 7x plus 2. Now, rather than going all crazy and cleaning up the left side, I'm not going to do it. All I need to know is that I've got an x squared here, an x squared here, and an x squared there. 2 plus b equals -2. Those are my coefficients for x squared. And I solve and I get b equals -4. Like we had up here. So if you like doing the system of equations, you can still do that. Or you can plug stuff in and it kind of cancels stuff out as you're going. And how did you pick x equals 1 and x equals 0? Because those are the ones that made everything go away. That's how this got easy. The way I picked it is I went, what's going to make this go away? What values for x can I plug in that's going to make shit go away? And I see if I plug in 1, 1 minus 1 goes to 0 on both of these. And I'm just left with that. If I say x equals 0, I've got this times 0 and this times 0. Those all go away when x equals 0. This one doesn't because it's 0 minus 1 squared. So you pick them to be the things that make the parentheses 0. This might be easier with another example. Let's do another example. You guys ready for more? Let's do 4x squared plus 6x minus 10 over x plus 3 times x squared plus x plus 2. that trinomial does not factor. So we will have a denominator of x plus 3. And we will have a denominator of x squared plus x plus 2. This one 1 degree smaller is just a constant. On this one, 1 degree smaller means I have to have an x in there. So I'm going to have a bx plus c. That's the hardest one for most students to remember. I know it was for me. And I liked this topic. So I imagine that's will be hard for you guys to remember as well.
Why was it bx plus 2?
Ideally, when you do synthetic division, that's when you're doing synthetic division, the smallest or the largest thing you can have on top is still going to have an x in it. Because there's an x squared down here. If there was an x cubed down here and it was like something that had x cubed all the way through that you could not factor, then we could have an x squared and an x and a constant.
So it's always going to be 1 degree smaller.
It's always 1 degree smaller.
And the c is just tacked on because they would be.
Because there might be a constant that goes with it.
And it's not as good.
Some of these might be 0. You might end up with things that are 0. So, but we don't know that ahead of time. So we got to put in variables. We'll do another one like this in a second, because this is the harder one to remember. Again, we're going to clear fractions. Here, it's kind of like we do this thing because there's only 2 fractions. This is a times x squared plus x plus 2 plus b times x plus 3. And I kind of want to exploit the x minus 3 thing, or the 0 thing out thing, where I don't have to do a system of equations. So this is x plus 3. If I set it equal to 0, I could find out x equals -3 destroys some shit. So if I stick in -3, I have 4 times -3 squared plus 6 times -3 minus 10 equals a times -3 squared plus -3 plus 2. Here, this is -3 squared is 9 times 4 is 36 minus 18 minus 10. If I subtract that, I get 8. On the right side, I have -3 squared is 9, minus 3 is 6, plus 2 is 8. I have 8a. And I can see that a equals 1. Something doesn't feel right. Maybe it's just some fucking tripping. All right, so now we need to find b.
Wait, so when you did the cross multiply, you multiplied the x plus 3 just times the b?
Oh, I fucked that up. That's why I'm tripping out. This is bx plus c times x plus 3. Thank you. I knew something was bothering me and I didn't know what it was. The same thing still, all this other shit works out now though, still. Because the -3 makes this entire thing go to 0. I knew something was nagging me. I knew I'd done something wrong and I didn't know what it was. That's what you were talking about, right, Chris?
Yes, it was.
Okay. All right, so we got that one. Now we need B. I can see that I have A, the easiest way I can do it. I can see when I multiply this out, I have an AX squared here, and I have a BX squared here, plus a bunch of other shit. Here, I've got a 4x squared plus a bunch of other shit. So I can find out what B is real quick, because A equals 1. I've got 4 equals 1 plus B. So B equals 3. So now I've got A equals 1, B equals 2, and I need to find C. Let's take a look at the terms that have a C in them. I have C times X, and I have C times 3, or 3C. I think the easiest one to focus on. I wonder if I should just do this all out. I'm going to do this all out first. I'm going to plug in A and B, and we're going to multiply it all out first, and then I'm going to show you what my thoughts were. If I plug in 1 for A, I have X squared plus X plus 2. If I plug in 2 for that, I have 2X plus C. times X.
1 sec. So you said 4 equals 1 plus B. You said B equals C, B equals 3, and then you wrote down B equals 2.
Yeah, I see that as I'm doing it. Thank you. I'm tripping. Straight up tripping. I flustered myself writing down the wrong thing up in the beginning. Good catch again. All right, that's what I have. I need to multiply this shit out. Plus 9x plus cx plus 3c. Now you see that here and that here. Okay, so we either focus, I gotta find out the coefficients for either the x or I can do the constants. If I do the x's, I have an x there, I have an x there, and I have an x there. There's more work to do. If I focus on the constants, I only have a constant here, and I only have a constant here. So that might be the easiest thing to do, is use the constants. I'm going to have 2 plus 3c here. And on the left side, the constant is -10. So we solve. And I get 4x squared plus 6x minus 10 over x plus 3 times x squared plus x plus 2 equals 1 over x plus 3 plus 3x minus 4 over x squared plus x plus 2. Ready for more? Okay, what's a good one here to do? Let's combine some shit. Let's have negative 3x plus, oh wait, hold on, no, let's not do that one. Let's do 10x squared minus 73x plus 144. All of that over x times x minus 4 squared. This isn't combining some shit, but it's some good practice. This is the hardest, one of the hardest topics in this class, so I think we should go back. This does not have an x squared in it, so none of the numerators are going to have an x in it. So, what factors should I put on bottom? Who's going to be the gutsy one that gives me ideas? Anybody? Go through them one at a time. First thing we have is an x. That's got to go on bottom. Now we have an x minus 1 4 squared. 1 4. What the fuck am I saying out loud? X minus 4 squared. Since it's squared, we got to have one that isn't squared. And one that is squared. I don't have anything like that ax squared plus bx plus c, so I can just put constants on top. Now we're going to multiply through by the denominator. X times x minus 4 times x minus 4. So the left side still 10x squared minus 73x plus 144. The a gets stuck with an x minus 1 4 squared. The a has that one. The b has the x minus 4. One of the x minus 4s, so it's left with x times x minus 4. And the c has 2 of the x minus 4s already, so it's just left with an x. What happens when what's the easiest way to go through this? How can I clear some values really quickly? What values can I plug in? 4, I can plug in a 4. If x equals 4, what do we get? I get a cx on the right, because the a and the b go 0. On the left, I get 10 times 4 squared minus 73 times 4 plus 144. And the x is 4, so it's 4c, sorry. This is 160 minus, let's see, 70 times 4 is 280, and then 12 is 292 plus 144. Let's see, I have 304 minus 292. This is 12. So c equals 3. This is my box I'm trying to fill in. All right. Is everyone good with what we did there? What else can I stick in that will clear some stuff out? Better question, if you look at these up here, what will make a denominator go to 0 up here? X equals 0, yeah. X equals 0 is always a sneaky one for students. Because it's like, no, that's just too easy or something, don't know. If I do X equals 0 here, my left side is just 144, right? And I have A times -4 squared. Then I got 0B and 0C. So this is 144 equals 16A. So we divide by 16 and what do we get? That looks like 9. Somebody do that in a calculator, make sure that's a 9. It's a 9, okay. All right, now all we need left is B. I can deal with something that has x squared, because if I multiply this out, I will have bx squared minus 4bx. So I need to look at the x squareds or the x's. If I look at the x's, I have to include the c. I have to multiply all this shit out to find out the x's in this one. I don't like the x's. I'm going to focus on the x squareds. If I focus on the x squareds, I have 10x squared over here. Notice that the only x squared I get from this parentheses is an ax squared. That's the only other spot that an x squared shows up here. Does that make sense? Without having to write everything out? The idea here is to save yourself some work. There's no x squared here. We already know that there's a bx squared here. And this is x minus 4 times x minus 4. You got x squared minus 8x plus 16. And there's an a on the outside. So I'll have an ax squared there. But I know a is 9. If I get rid of the x squareds, I have 10 equals 9 plus b. So what does b have to equal? One. So I can come down here and write all that stuff out. So my A was 9, and that was just over x. My B was 1, and that was over x minus 4. And my C was 3, and that was over x minus 4 squared.
I have a question.
Yeah.
Can you write the 3 system of equations that get you that you would use in this example?
Yes. So let's show it the other way. Not everyone likes this method. Everyone got this part down. Let's go back to doing the other way, but it all starts after the fractions are cleared. So, if you like the system method, system of equations approach. We have to multiply out the right side. This is a times x squared minus 8x plus 16 plus bx squared minus 4bx plus cx. So I have ax squared minus 8ax plus 16 plus bx squared minus 4bx plus cx. Plus 16a, I'm missing that. So if I look at my x squareds, my x squareds have a plus b equals 10. My x's are these. And I have negative 8a plus b plus c equals negative 73. And finally, my constants. 144 equals 16a. So if we did it this way, we divide by 16, we get a equals 9. I would come over here and plug that in here. I get 9 plus b equals 10. So b equals 1. I would plug them both in there. I would say negative 8 times 9 plus 1 plus c equals negative 73. This is negative 72 plus 1 is negative 71. Oh, sorry, just add 71 to both sides. And I get c equals negative 2. That doesn't feel like what I had a second ago.
I did the exact same thing, exactly the same way you did it, and you doing it made me realize the mistake I made. The second equation is minus negative 8a minus 4b, right? Plus c.
So this is minus 4 times 1. That changes this. So I got c plus 76. No, c minus 76 equals negative 73. So I add 76 to both sides and I get c equals 3. Now, here, this actually looks a little bit easier, right? Than the other method. I mean, I did have to multiply it all out, and I did have to presumably not fuck up setting up the equations. Right? So there's that. But once this gave me A right away, this gave me B right away, this gave me C. Once I got through the cleaning, writing everything out, setting it up, that's what happens. Let's take a look at one where it's like you're like, nope, don't want to do that. People still writing. Let me slow my roll, Jones. x squared minus 18x plus 5 over x minus 1, x plus 2, x plus x minus 3. Okay, so each of these only show up once and there's no x squareds on bottom. We just make each one a denominator. And when you clear denominators, every letter gets the denominator of the other ones. So A gets x plus 2 and x minus 3. B gets x minus 1 and x minus 3. And C gets x minus 1 and x plus 2. So if you like the systems method, you're not going to like it here. Because there's a shitload of work to do here to get to the systems method. We're going to do that real quick, just to show, illustrate. I need to multiply this out first. I get x squared. I get plus 2x minus 3x is minus x. And then 2 times negative 3 is negative 6. And I do the same thing with the b. And I get x squared minus x and plus 3x is plus 2x, then minus 3. And finally, for the last one, I get x squared minus x plus 2x is plus x minus 2. Then you got to distribute. I think while you're distributing, this might be easier to stack shit that's got the, should teach this in this way in the future. Just had a fucking epiphany. Start stacking it underneath where the other things that have the same variables. I got b times x squared, let's put it there. I've got b times 2x, let's put 2bx here. I got b times negative 3, I got minus 3b here. This is having a great idea here. This makes it a little bit easier to do the system of equations. Cx squareds go under the x squareds. C times x goes under the x's. And c times negative 2c goes under the things without x's. So, if I add that up, my x squareds have a plus b plus c times x squared. My x's have the coefficients of this column. Minus a plus 2b plus c. And my constant is just everything else. Minus 6a, minus 3b, minus 2c. That all equals x squared minus 18x plus 5. Okay, so here you would have this goes with that. So A plus B plus C equals 1. That goes with that. Negative A plus 2B plus C equals negative 18. And finally, negative 6A minus 3B minus 2C equals 5. I am not going any further down that road. We can already see that's a lot of work to solve. Let's go back and look at the other approach. Back to the cleared fractions, but we didn't do anything with it. Look. Okay, so once you have it set up, the easiest way to go about going through this, look at the original denominators and go, if I make this denominator 0, does it clear out a bunch of shit? Here, to make this denominator 0, I gotta say x equals 1, right? If I say x equals 1, this goes to 0, that goes to 0. So it does, it clears out B and C. So let's do x equals 1 first. The left side is 1 squared minus 18 times 1 plus 5 equals A times 1 plus 2 and 1 minus 3. I get negative 12 equals 1 plus 2 is 3 and 1 minus 3 is negative 2, negative 6a on the right. So I can see that a is going to equal 2. Everybody with me on that? Now do the next one. If I stick in negative 2, this goes to 0. Will that help up here? If I stick in negative 2, the A is going to go away. And the C will go away. So negative 2 is a good combination to stick in. This is 4 plus 36 plus 5 is 45. And on the right, we have negative 3 times 1, negative 3b. B equals negative 15. That's a big number. And finally, if I do the last one, the value that will make this denominator 0 is x equals 3. So let's do x equals 3. I have 3 squared minus 18 times 3 plus 5 equals. Plugging in 3 will zero out the A, because 3 minus 3 is 0. It will zero out, that should have been a minus sign right there. Oh, damn, that's gonna fuck some shit up right there. Right there. So this was -3 times -5. So that was 15. That changes shit. So B equals 3. I noticed plugging in the things showed me that I had something wrong. Like I made sure I saw that I fucked something up. This should have been a negative up here too. And I fucked it up there too. Which means something along the way up here was off. This whole thing would have been different. But doing it here, I would have never caught it here. Here, plugging in the values of each showed me that no, this shit didn't go to 0 the way I had it. The only ones that's left is the C. And I got 3 minus 1 and 3 plus 2. And that's going to give me 2 times 5. So I get 10C on the right. On the left, I have 9 minus 54 plus not 5. Negative 40. So C equals -4. So I just put it all together. X squared minus 18x plus 5 over x minus 1, x plus 2, x minus 3 equals. My x minus 1 has a 2 on top. My x plus 2 has a 3 on top. And my x minus 3 has a -4 on top. That's fine. Okay, let's do something like this. And I don't think I'll finish, but we'll look at the setup. I think the setup and finding fractions is the hardest part. Let's look at setting up x to the 4th plus x cubed plus x squared plus x plus 3. I don't know. Fuck it. I've got x times x squared plus 1 squared. I just made up the numerator, so it's probably, if you try to solve this, it's going to have shitty answers. But we can at least show the setup. The setup is the hardest part. I should have something that has an x on bottom. I should have something that has an x squared plus 1 on bottom. And since it's squared, I should have another one, x squared plus 1 squared. This really is like an ax squared plus bx plus c, where b equals 0, which means if I do a here, this one needs an x with it. If I see the squared, I gotta have one smaller on the exponent. And I'm gonna have a dx plus e here. And if I clear fractions, the a gets the x squared plus 1 squared. The bx plus c gets an x and an x squared plus 1. And the dx plus e only gets an x. And there's nothing you can try. If you plug in x equals 0, you can get a. That's about all we can do here. We plug in x equals 0. We get 3 on the left side. On the right side, it's a times 1 squared. This is going to make the bx plus c go to 0, and this is going to make the dx plus e go to 0, which means that's it. A equals 3. Actually, we got still some time. Let's see what this multiplies out to. X squared plus 1 squared is like that, which is x to the 4th plus 2x squared plus 1. And now I need to multiply it by a. I get ax to the 4th plus 2ax squared plus a. This one's going to look ugly. I'm going to add, let's figure out what this one is. So that's the first one. Now we've got bx squared plus cx times x squared plus 1. I've got bx to the 4th plus bx squared plus cx cubed plus cx. That's one set I got to add up. And that here is just dx squared plus ex. So let's start lining these up. That's my A set. My B set is like this. And my dx squared plus ex is like this. And I know a is 3, so I'm going to plug in a equals 3. 3 plus b times x to the 4th plus cx cubed plus 6 plus b plus dx squared plus c plus ex. And we already knew the a was 3. This actually isn't too bad. I know a equals 3. If I look at equating, there's only 1x cubed, look at that. 1x cubed tells me there's a c on the right and it's 1 on the left. C's got to be 1. I can see that 3 plus b has got to equal 1. So b equals -2. On my x squareds, I've got 6 plus b is -2 plus d. So I'm doing this one right now. That has to equal 1, the coefficients. So this is 4 plus d equals 1, d equals -3. And finally, I can get my e here on the x. So c I have is 1. 1 plus e equals 1. So e equals 0. That actually all cleaned up very easy. Not too bad. Pain in the ass is multiplying all this shit out. Now, I'm assuming I did it correctly. If I were doing this on the test, I'd go back over and look at this shit real close. But I'm not gonna, the partial fraction decomposition test problem is an extra credit problem. You're not gonna have one on the test. You're not gonna have I'm not gonna test you on partial fraction decomposition because you don't need it for a little while. But it will be the extra credit one, and I strongly recommend doing it. If I rewrite this now, I had x to the 4th plus x cubed plus x squared plus x plus 3 over x times x squared plus 1 squared. I had this over x, and then I had over x squared plus 1, and then I had over x squared plus 1 squared. I'm just copying down what we had up here. My a is 3. B is -2 and C is 1, gives me -2x plus 1 right here. And D is -3, E is 0, gives me -3x here. So that's how it decomposes. Any questions?
I have 2 questions.
Yes.
So you've probably already said this many times, but if we take trig, which is pre-calculus B over summer, we can take calculus 1 with you in fall?
Yes, you don't, if you take pre-calc B or trig, you'll be able to enroll in calculus with me in the fall.
Also, what is the next test day? Like, when's the next day with being class in person?
It's on the syllabus, it's the final day.
The final, oh, so the 17th?
Yeah, if that's when the final is. I'm not looking at
Okay.
it right now, so,
Okay.
okay. That's it, y'all can get out, go on get. Go on get.
Thanks.
Right, that's what I was going for. Some southern shit right there. This is actually a cool topic, because we've done factoring when it's in the numerator, but we haven't factored in the denominator before.